free languages, the machine that we are going to use is the pushdown automata using the stack. Okay, so in the hierarchy, in the Chomsky hierarchy, the first level what we have seen is about regular languages, and then we have, so since not all the languages could come under the regular languages, since we need to have more complicated languages, we go for the next level of next level in the hierarchy, which is the context-free languages. Okay, so for context-free languages, we have the machine pushdown automata using the stack memory. Okay, so that day we have seen how we can solve the language context-free language A power n, B power n. Okay, so today we will see two more examples. So since we have very less time, I want to finish it within because only if we finish those two problems within an hour, you will be able to understand the concept behind it. So kindly listen carefully. Have your notebook with you. Hope you are all listening. So the next language that we are going to do with this context-free language is that language L is equal to WC W reverse. Is it visible clearly? For me, it is glaring. Is it visible clearly? Yes or no?
No, ma'am, it's glaring.
Now? Now is it clear? Okay, thank you, ma'am. So the next language that we are going to study is about the WCW reverse, such that W belongs to A comma B, the whole star. Okay. So this is the language we are going to solve it using the pushdown automata today. So what does this language says? The W part, it is consisting of A comma B, the whole star. Okay, so you can make any string out of this A and B for W. So whatever you make it for W, the reverse of that comes after this C. Okay, so for example, we can have the language like, so if I'm having AB, W is equal to AB. If I'm having W is equal to AB, then followed by C, followed by W reverse. Okay, so reverse of this string is BA. Okay, so similarly, you can have any string. Okay, for example, if I'm having BA as W and followed by C, then W reverse will be AB. Okay, so like this, you can have any kind of string made up of A and B for W, and the reverse of that will be at the end. So this is your language. So to accept the strings that are present in this language, we are going to construct a pushdown automata, or we are going to design a pushdown automata. So what we can do for doing this particular, for accepting these kind of strings is that the stack what we are going to use, what we are going to do, till you are reading the characters in the string W, you can just keep on pushing it into the stack. Okay, whatever it may be. Okay, it may be because here there is no order of the characters. Okay, anything may come. Okay, A and B come in any order in the string. Okay, so whatever the character it may be, either A or B, you just keep on pushing it into the stack. Okay, until you read C. Okay, so now what is this C character actually it is telling is that this is the middle of the string, right? This is the middle of the string that is disconnecting W and W reverse. Okay, or we can say that this is the middle point for the string which is separating this W and W reverse. Okay, so definitely we know that before C what we are having is W, and after C what we are having is W reverse. Okay, so we keep on pushing all the characters from W, and when C comes we are going to change the state. Okay, so after changing the state we are going to read W reverse and check. So you can see here the last character of your W and the first character of your W reverse will be same, right? The last character in your W and the first character in your W reverse will be same. Similarly, it keeps going on. Okay, so the last character and the first character, and here the second character and the next to last character. Okay, so like this it will be coming. So what you will be having in the stack, you will be having first you will push A and then you will push B, okay, and then you will again push B. Okay, so you keep on, as you keep on reading one character by another character, you keep on pushing it into the stack. Okay, so this is what you will have in the stack. So when you read C, now you can know that the what comes next will be W reverse. Okay, so while you're reading C, you're not going to do anything. You're not going to push this C, or no action will be taken at this point. Okay. So immediately after that, you're going to change the stage, and then whatever the characters you're going to read, you're going to check the input that you're reading and the top of the stack. Okay. So obviously it should be matching. Okay. If the string belongs to this language, then obviously the W reverse character that you are going to read and the top of the stack should be matching. Okay, so the first character in the W reverse is B and the top of the stack is also B. Okay, so you can pop it off. And then the next character when you read, now this will be the top of the stack. Okay, this is removed from the, this is popped out. So now this is the top of the stack. So when you read this, the input string that you read, input character that you read, and the top of the stack matches. Okay, so you can pop it. And then when you read A, the top of the stack is A here, so you can pop it. Okay, so that means when you complete reading the entire string, the stack also becomes empty. Okay, so that shows that this particular string belongs to this language and it is accepted by the machine designed by us. Okay, so this is the logic we are going to use for writing the transition functions for this particular pushdown automata. Okay, now how will you write the transition function? So while you're writing the transition function, what you want to keep in mind is that in your stack, in your string, anything may come first. Okay, for this particular language, your initial input may be either A or it may be B, right? Because your W belongs to AB the whole star. So the W may be consisting of strings, anything. Okay. So here you can see it is made up of, it is AB and here it is BA. So that means the initial character that you are reading is either A or B. Both are acceptable. Okay. So you need to write the transition function which accommodates both the things. Okay. So delta of, when the initial state is Q naught, okay, and you have your stack initial stack symbol is Z. Okay, initial stack symbol is Z. So now here the input, okay, the input that you are going to read, it may be either A, okay, or it may be B. I hope you understand. Okay, when the stack is empty, okay, we are representing it using the stack start symbol Z, and initially when you read, it may be either the input A or it may be B. Okay, so for some strings it may start with A, or for some string it may start with B. Okay, but whatever comes to the machine, okay, if you give this particular string to your machine, the machine should accept this string. And if you are giving this input to the machine, it should accept this also, because both are correct and both belongs to the language. Okay, so we need to write the transition function accordingly. So whatever it comes, okay, whatever the input that comes, you are going to push it into the stack. Okay, so actually, why we are writing it as A is that what is the meaning of this? What you are writing it here is the contents that you are going to replace with the top of the stack. Okay. So what is the top of the stack initially? The top of the stack is Z. Okay. So now you are saying that replace the top of the stack with this string. Okay, while you're pushing this string into the stack, you should remember that this should always come into the leftmost should come in the top of the stack. Okay, that is the meaning. So when you are doing so, you are replacing means you are popping out this and you are replacing again with this particular string. Okay, you are replacing the top of the stack with AZ. So again, you will get in your stack Z in the bottom and A in the top. Okay. So similarly, here also we have Q0 comma BZ. So whatever may come in the initial character, that will go to the stack. Okay. And then, so now you have two possibilities. Your string may have A as the top of the stack. Please understand, we are not using two possibilities. Okay. So this is possibility 1 and this is possibility 2. Okay, based on your input. Okay, so we are not going to we are going to write a generalized machine which will accept any string that belongs to the language. Okay, so we have to design the machine which accommodates whatever the string that comes in that language. Okay, so we have now two possibilities. Either your stack may have A as the top of the stack, or it may have B as the top of the stack. Okay, so if your string starts with B, then this transition function will be applied and B will go into the stack. Or if your string starts with A, then this transition function will be applied and A will go into the stack. Okay, so there are two possibilities. Now again, now the next input. Okay, so now what is the top of the stack? It may be A or it may be B. Okay, the top of the stack may be either A or it may be B. Okay, whatever it may be. And when the top of the stack is A, your input may be anything. Okay, so you have now uh, four different possibilities actually. Okay, why four different possibilities? When the top of the stack is A, you may read the input as A. Okay, or you can write it this way, it will be easier for you. Okay, when the top of the stack is A, your input symbol may be, current input symbol may be A. Okay, or when the top of the stack is A, your current input symbol may be B. Okay, and when the top of the stack is B, your input symbol may be A, and when the top of the stack is B, your input may be B. I hope you understand. What is this? You are reading the next character. Okay, so initially when the top of the stack is empty, when the stack is empty, you read either A or B and you have updated the stack. Okay, and now you continue to read your next character. Okay, so if the string is this, what you are getting, this may be anything. Okay, this the second character, what may be anything, A or B. Okay, so when the top of the stack is A, And if you are reading A as your current input symbol, then what you have to do? Okay. Or if you are reading the current input symbol as B, what you have to do? Okay. So all the transition functions we are writing is generalized one. Okay. So whatever the input that comes into the machine, it will apply the transition function accordingly. Okay. So now what these four situations may occur. Okay. When the top of the stack is A, your input symbol may be either A or B. Similarly, if the top of the stack, when the top of the stack is B, your input may be either A or B. Okay. So we are not changing the state at all these points. We are simply having the state Q naught. So what we are doing, we are just pushing it into the stack. Okay, replacing. So what will happen if this particular transition function is applied? This A will be replaced by AA. So again, actually, AA will come. Okay, you are replacing this A with AA. Okay, or you may be replacing this A with BA. Okay, so then that means B will come to the B will be at the top of the stack. The leftmost will be at the top of the stack. Okay. So like this, your stack will change. Okay. So I hope you understand these four transition functions. So next, so now this transition functions will help you to push all the input symbols that are present in the W. Okay, so whatever may come, it keeps on pushing it into the stack. Okay, now when you start reading C, okay, now when you start reading C, what you have to do? So it means that when you read C, again there are two possibilities. Your top of the stack may be either A, or the top of the stack may be either maybe B. Okay, so whatever it is, no, now you know that this C is the middle of the string. Okay, so at this point you are not going to do any push or pop, but just going to change the state. Okay, you are just going to change the state. Okay, so now the top of the stack is already A, and the replacing string that you are giving is A, so that means it will not change anything. Okay, it is going to be the same. Okay, the top of the stack already, if A is there, then A will be again replaced by A. Okay, or B will be again replaced by B. So no change in the stack will happen. So it remains the same. Now the state has been changed to Q1. Okay. Now again, your input in the, top of the stack may be either you'll be having A or you'll be having B. Okay. Now, as we have seen here, what you have to do, it is known that for this particular language, if the strings belong to this language, then definitely the first character in the W reverse and the top of the stack. What is top of the stack? The last character in your W. Okay, so this belongs to W and this belongs to W reverse. Okay, so this is the last character in the W that is present in the top of the stack. Okay, and this is the first character in the W reverse, which you are now reading. Okay, so obviously for this particular language, the last character and the top of the stack is matching. Okay, so you are going to write that as your transition function. So when both the top of the stack and input matches, okay, if the top of the stack is A and input is A, or if top of the stack is B and input is B, then what you are going to do? You are going to pop it out from the stack. A pop operation has to be taken place here. Okay, so how will you represent the pop operation? The pop operation can be represented using a lambda. So basically what is this? this is what you are going to, the string that is going to be replaced in the place of top of the stack. So you are replacing lambda in the place of top of the stack. That means B will be replaced with lambda. So lambda is obviously a, so if you are having B in the top of the stack, you are replacing this with lambda. Lambda is obviously an empty string. Okay, so that doesn't matter. Okay, so now the top of the stack becomes B. Okay, so you are just going to do a pop operation using this lambda. Okay, so as you keep applying this transition functions, the all the symbols in the W reverse will get eliminated from the top of the stack. Okay, so finally you will be having your all the strings in the all the characters in the input string got exhausted. Okay, so you have finished reading your input. Okay, you have finished reading your input, and there is no more character left behind in the input string. So lambda, and the stack should also become empty. Only then you will be reaching the final state. Okay, you will be reaching the final state when the input gets exhausted and the stack also becomes empty, you reach the final state. Okay, is it clear? Do you understand this? Can I get some response so that we can continue to the next problem? Or if you have any doubt, please ask. Don't hesitate to ask any doubts, or at least say whether you understand it or not. If it is no, kindly put a no in the chat box. If it is yes, yes, Johnson, thank you. What about others? There are 70 in the meet. I need a response from many of you, most of you. Only then I can continue, because this is an important problem. Only after getting response from all of you, I'll be moving on to the next problem. Don't waste the time, please. Yes, I hope you take it down in your notebook, because I'm going to erase this and I'm going to go for the next problem. Okay, thank you, students. The next problem is going to be little bit similar, but it requires little more understanding also. Okay. L is equal to W reverse, such that W belongs to 0, 1 the whole star. Okay, here the input symbols we have taken as 0, 1. The thing is, here also we are going to do a similar thing corresponding to the previous problem. But the thing is, here there is no middleman. Okay, there is no middle character that separates this W and W reverse. So there we are able to see that very clearly. The C will, after C, W reverse will start. Okay, but here what are all the strings that will come? See, for example, so this tells that W belongs to 0, 1 the whole star. So using 0 and 1, anything can be made. So for example, 0, 1. Okay, 0, 1 is the string W, assume. Okay, so what will be W reverse? It will be 1, 0. Okay, this is W reverse. So like this, so for example, 1, 1, 0. Okay, and then so this is W, not comma. This is W. So W reverse will be 0, 1, 1. Okay. So actually, by manually looking this, we may be able to understand which is the middle of the string. Okay, we may be familiar with this. By looking at the string, we'll be able to identify that. Okay, but the problem is, let us take one more string, 0 0 1 1 0 0. Okay, so we have so many string searches like this. Okay, the problem is, what we have done in the previous problem is that when before C, we keep on pushing all the characters into the stack, and after C, when the top of the stack and the last character matches, we say that we pop it and say that the W reverse and W are same. Okay, so we are trying to match that. So here the C was there to separate the W and W reverse. But the thing is, here we are not able to do it very exactly. Why so? See here in this particular example, we have 0, 1 and 1, 0. Okay. So when two ones come together or when two zeros come together, okay, like here, okay, when two ones come together or when two zeros come together, okay, or the two same symbols come together, we may assume, okay, we may assume that that gives you the middle of the string. Okay, but that is not the exact option to take on. Okay, because there is another possibility, two same symbols may come within the string also. Is it clear? In this example, when two symbols come together, we can assume that that may be the middle of the string. But that may not be the case always, because within the string itself, two same symbols come together. Okay. So what we are going to do is we are going to apply non-determinism here. Okay. So what is non-determinism? Non-determinism will give you multiple options. Okay. When you write a transition function, you can have multiple choices. Okay, so either when two symbols come together, it may be the middle of the string or it may be part of the same string. Okay, so both the choices or both the options we need to give in the transition function that we write. Okay, so let us start writing. If you want, you can use it, you can use you can use different stack symbols or the same one. Okay, let me use the same thing so that it will be easier for you to understand. Or sometimes we use a different symbol for stack symbols also. Okay, so in the same way how we have write the previous thing, we'll write here also. The initial state is Q naught, okay, and the stack symbol is initially the stack is having the initial stack symbol, that is Z. So now here also we have two possibilities. Your input may start with 0 or your input may start with 1. Okay, your input may start with 0 or your input may start with 1. Both are possible. So when so you are just going to push it into the stack. Okay, we are going to just push it into the stack. Now, again, so now the stack may be having 0 as the top of the stack, or it may have having 1 as the top of the stack. So if we are having 0 as the top of the stack, again we have two possibilities of input symbol. Either it may be 0 or it may be 1. Okay, and when the top of the stack is 1, again we have two possibilities. The input may be 0 or the input may be 1. Okay, so for all these four possibilities, we are going to write the transition function. Okay, so how will you write? First we'll write the normally what will happen. Okay, so assuming that this is part of the string. Okay, actually we have both the possibilities. We assume now all these are part of only W. Okay, like how we have write it for before C, we are going to write the transition function. Okay, so assuming that these are all part of the, when the top of the stack is 0, we are reading the input from W. Okay, assuming that when you write, what will you write? You are replacing the top of the stack with 0 0, and here you are replacing it with 1 0, and here replacing it with 0 1, and here replacing it with 1 1 1. Okay, now we have written this assuming that whatever you are reading the input symbol, it is part of the W. It is part of W. Okay. But as we have discussed, it may not be so. Okay. In which one? When you are reading two symbols together. Okay. When, so for this transition function and for this transition function, there may be another chance also. Okay. When you are reading two symbols together, it may be the middle of the string. Okay. Separating your W and W reverse. Okay. So what we have written is assuming that it's all part of W. Okay. But there is another possibility also when two symbols come together. That is when your top of the stack and your input symbol is same. Okay. Here also, when your top of the stack and when your input symbol is same, there is a possibility that it may be the middle of the string. Okay. So in such case, what we need to do, if it becomes the middle of the string, we need to change the state. Okay, assuming that is going to be the next. We are just going to read from the W reverse. Okay, we need to change the state. So for these two things, we have another option. Okay, either this may happen or you have another option Q1 comma lambda. Okay, so when two symbols come together, as you are doing for your previous thing after C, here when two symbols come together, we assume that this may be the middle of the string, and we can change the state, and you can pop out the same symbol. Okay, as we have done earlier. So here we are applying the non-deterministic nature. Similarly, here also we can change the state and do the pop operation. Okay, so now after moving on to state Q1, if you have both input and the top of the stack is same, then again the pop operation will continue. Okay, this is similar to what we have done earlier. So when both the symbols are same in state Q1, we are just popping out. Okay, and when the input got exhausted in state Q1, and when the stack becomes empty, then we reach the final state. So this you will understand only when we apply some example and see. Okay. So quickly I'll give you this. So I hope you have written this part in your notebook. Okay. Have you written it? Because this you need when I'm doing it for the next portion, because we are just going to apply this transition function for a particular example. Okay, so then you need to know the transition functions. Only if you have written it in your notebook, you'll be able to follow me when I'm doing that example. Have you done it, ma'am? Shall I rub it? Can I get some response from you? Or are you still writing? Yes, Nancy said yes. What about others? Nancy Johnson, other than that, yes, others? Can I rub this? Yes, please, all of you respond. Shall I rub it? Please take down all these transition functions. Okay, I'll rub this. We'll move on to an example. We'll apply this transition function for a particular example and see how it works. Okay. So for this, you need to know about one thing called instantaneous description. Okay. So this instantaneous description will have three parts. Quickly, I'll tell and give the example. So it's going to be a three-part Q, W, and U. Okay. So this Q will be the state. Okay. What we are using Q0, Q1, and so on. And this W is unread part of the string. Unread part of the string. That is, as you keep reading the input string one by one. So, for example, if you are having ABB, now you have read A, so remaining is BB. Okay. After reading B, what is remaining is only the single B. Okay, like that. Unread part of the string, and U is the stack contents. So what is now presently available in the stack content? So here also the leftmost symbol, okay, the leftmost symbol should be top of the stack. You should write it in that way. Okay, please make a note of this. Q is the state of the control unit, and this W, it will give you the unread part of the string, and U will be the stack contents. Okay, so now we are going to use an example, and I'll tell you how to do it. So for this particular example, W reverse, we'll take one example. Okay, let us take 0, 1, 1, 1, 1, 0. Okay, so this is an example from the language W reverse. So this is W and this is W reverse. So by manually looking into it, we'll be able to know that this is the middle. Okay, but when we apply it to the machine that we have designed, we will see how it works. Okay, so Q0, okay, the state, the current initial state will take Q0, and so what is the string that we have taken? 0, 1, 1, 1, 1, 0, and now the stack content is Z. Okay, now the stack content is Z. So now we are going to apply this, apply the transition functions. So now you should know actually what is the transition function. So that is why I told you it should be in your notebook. Okay. Now you check in your notebook what is Q0, comma 0, comma Z. Okay. You would have written a transition function Q0, 0, Z. What we have written there, it is actually Q0, comma 0, Z, right? So after doing the transition, what is remaining? The state will be remaining the same. And what is the remaining part of the string? 0 we have read now. Okay, so that is what we have read. Q0 is 0 and Z. The remaining will be 1, 1, 1, 1, 0. And now what is the stack content? So the stack will be now 0 Z. Okay, so the stack contents will be 0 Z. 0 is the top of the stack. Okay, and now we want to again apply here. So Q0, the next input that you are going to read is 1, and what is present in top of the stack? 0. Okay, So what is your transition Q0, comma 1, comma 0? Q0, comma 1, comma 0 you would have written in your notebook, right? What is that? Simply it is going to be you are pushing 1 0 into the stack. So Q0. Now what is the remaining part of the string? 1 1 1 0. And when you push this into the stack, what is your entire stack contents? It will be 1 0 is it? Okay. So what happens? The 0 is replaced by 1 0. So your stack contents will be 1 0 is it? Okay. When you are writing, the top of the stack should be in the leftmost symbol. Okay. So Q0, the remaining part of the string is 1110 and this is 10 is it? Okay. Now you see what we are having Q0 1 1. Q0 1 1. So if you check in your notebook, you can see that we have two options here. Okay, delta of Q0 comma 1 comma 1. We have written two options. One is Q0 comma 1 1 and another option is Q1 comma lambda. Yes, I hope you have checked in your notebook. Okay, we have two options. Okay, so we do not know which one to apply. Okay, so let us apply both of them. So that is what we have applied the non-deterministic nature here. So it may be this or it may be this. So if you apply this one, what will be your result? The state will be Q0 and the resultant remaining string will be 110. This is the unread part of the string. Okay, this we have read now and the unread part is 110. Okay, and when you apply this to your, when you push this into your, replace the top of the stack with the 1 1, what happens? 1 is replaced with 1 1. Okay, so 1 1, this 1 is, this top of the stack is replaced with 1 1. So 1 is replaced with 1 1, then 0 is it. Okay, so this will be our result. Or if you are going to apply this one, okay, then what happens? The top of the stack will be popped out. Okay, so and the state is changed to Q1. Okay, so Q1, the remaining part will be 110 and this will be popped out. So you will be having 0z in the stack. Okay, so by applying this option, we are getting this result, and when you apply this one, we are getting this. Okay, so at least in some way you should reach the final state. Okay, in any part if you are reaching the final state, then you can say that the given string is accepted by the machine. Okay, so then we can now see Q0 1 1. Okay, again we have two options. Okay, Q0 1 1. So what are the two options? So if you apply this one, Q0, the remaining part of the string is 10 and 1 is replaced by 1 1. So 1 1, then the remaining thing 10 is it. Okay, or if you are going to apply this one Q1 comma lambda, what you will get? The state becomes Q1, the remaining part is 10 and this will be popped out from the string. So what you are getting is 10 is it. Okay, and on this side we have Q1 1 0. Is there any transition function like Q1 1 0? No. Okay, I'm not having time to get response from you. So if you check your transition functions, there is no transition function at all. Q1 comma 1 comma 0. So this path is cut off. Now we'll move on to here. Q0 1 1. So again we have two options here. Q0 1 1. So when you apply this one, Q0, the remaining part is 0 and when 1 is replaced by 1 1, you will get 1 1 and then again 1 1 0 is it. Okay, or if you are going to apply the second option, then what will get? Q1 0. This what will, yes, yes, any doubt ma?
போட்ட டோஸுக்கு அதுக்கும் ரொம்ப நேரம் கழிச்சு தான் வேலை செய்யுது.
Okay, so this will be popped out. Then what you are getting is 1 1 0 is it. Okay, and here if you see Q1 1 1. Okay, so that means this will give you Q1 0, remaining part is 0, and lambda, when you apply popping
2 நாள்
option.
எந்திரிக்க முடியாதனால ஊசியை போட்டு
Hamsavardhan, kindly unmute your mic. Okay, so 0 is it. And when you come to this portion, this will be Q0 0 1. Okay, so Q0 0 1 means you will be having Q0. The remaining part will be now lambda and 0 1. So 1 should be replaced with 0 1. Then 1 1 1 0 is it. Okay, so what happens here? The string becomes empty, but the stack does not become empty. Okay, so this does not accept. But here again Q101, that also will be making you lambda, then 0 1 1 0 is it. Here also what happens? Stack string becomes empty, but the stack does not becomes empty. But when in this case, you can see here Q100. Okay, when Q100, what happens? This becomes Q1 lambda and Z. Okay, so when both are same, when you apply Q100 transition, delta of Q1 comma 0 comma 0 is equal to Q1 comma lambda comma Z. Okay, so that is Q1 comma lambda. You will be popping the operation. Okay, popping that. So when you finally find it out this way, now you can move on to the final stage. I hope you understand. Yes, do you understand this? Now you can say that in some way you are able to reach the final stage. Okay, so that means that this particular string belongs to the language. Do you understand this, ma'am? Yes or no? Can I get some response? Yes, thank you, students. So now what you do, we have already crossed the time. So put your register number in full caps in the chat box. That I will take it as attendance. Put your register number in full caps in the chat box. That will be taken as the attendance. So only if your register number is present in the chat box, your attendance will be considered, marked as present. So after giving your register number in the chat box, you can leave the meet. Thank you, students. Put your register number fully in caps, full caps. Put your register number in full caps. All capital letters.